Hello everyone, welcome back. So in this video, we will discuss the problem summed matrix. So a matrix of size n cross n where L will be given to you is being constructed and integer q will also be given to you and the value at every cell of the matrix is I plus j where I is the row number and j is the column number. Cool. So you have to return the number of cells which are having value q and we have to assume one base indexing. So let's see how we can solve this problem. But before moving on to the solution, if you haven't solved this problem yet, then please pause the video and try to think of a solution. So let us discuss one example first. For n is equal to 5, that is a matrix of size 5 cross 5 being constructed. And let's say the value of q is equal to 8. So the value of each cell is I plus j, where I is the row number and j is the column number. So for the first cell, row 1, column 0. So 1 plus 1, which is equal to 2. Then for the second cell, row 1, column 2, so 1 plus 2, which is equal to 3. Then for the third cell, 1 plus 3, which is equal to 4, and so on for all the other cells. So how many cells are having value 8? So there are 3 cells, so the expected output is 3. And if the value of q is 9, then the number of cells which are having value 9 is 2. So 2 is the expected output. So this problem is more on observational side. You have to draw some observations and handle some edge cases. So we know the value at each cell is I plus j. So this is definitely be less than or equal to 2n because I is the row number. There are n number of rows. J is the column number. N number of columns. So what if the value of q is greater than 2n? So then no cell is having value q. So in that case, we simply return 0. So this is the first case. If q is greater than 2n, then we simply return 0. Then the second observation, if you observe the left upward diagonal, and definitely if you observe here, then all the diagonals are having the same value. So left upward diagonal, basically this one. How many occurrences are 2 of 2? 1. How many cells are in this diagonal? That is how many occurrences of 3? It is 2. Then how many occurrences of 4? It is 3. How many occurrences of 5? It is 4. So can I say this thing? If q is less than or equal to n, then my answer will be q minus 1 because for 5, which is less than or equal to 5, value of n. So in this case, the number of cells which are having value 5 is 4. Then for 4 it's 3. Then for 3 it's 1. And for 3 it's 2. And for 2 it's 1. So this is the second observation. Now, if you draw the observation for these cases, then how many occurrences of 6? So the number of cells which are having value 6 is 5. The number of cells which are having value 7 is 4. Then the number of cells which are having value 8 is 3. And for 9, it is 2. And for 10, it is 1. So can I write this thing? That the number of cells which are having value q is 2 power 2 into n minus q and plus 1. Cool. So if you see this thing, then it is 5, 2 into 5 minus 6 and plus 1. So that is 4 plus 1, which is equal to 5. And 5 cells are there which are having value 6. Then let us test for one more example. Let's say 2. So how many cells are having value 9? 9. So it is 2 into 5 minus 9 and plus 1, which is equal to 10 minus 9, which is 1, and 1 plus 1, which is equal to 2. So there are 2 cells which are having value 9. So it's very simple. This is the first case. If the value of q is greater than 2n, then just simply return 0. And if the value of q is less than or equal to n, then simply return q minus 1. Otherwise, simply return 2n minus q plus 1. Cool. So this is the complete solution. Now let's see the implementation. So here I have declared the answer, and this is the first case. If the value of q is greater, then simply return 0. And this is the else part, else if part. If the value of n is greater than or equal to q, then my answer will be q minus 1. Otherwise, my answer will be 2 into n minus q and plus 1. And simply I am returning this answer. So talking about the time complexity, which is constant as we are not using any kind of iteration or recursion, and the space complexity is also constant as we are not using any extra space such as array, string, or something. Cool. So thank you so much.